Good morning, everyone. Today we're going to be talking about fitting a line to data. Now, this is chapter 5.6. And when we talk about fitting a line to data, we're talking about scatter plots. Now, a scatter plot is a graph used to determine whether there's a relationship between paired data. Scatter plots can show trends in the data. So, what a scatter plot is a bunch of these little points. If y tends to increase as x increases, the paired data are said to have a positive correlation. So if you look, this data looks like it's going uphill. It's going positive. That's a positive correlation. If y tends to decrease as x increases, the paired data are said to have a negative correlation. So this one's going downhill, negative. Then, if x and y have no apparent relationship, the paired data are said to have relatively no correlation. So if it's just a big jumble of dots and random orders, then it has no correlation. So it says, describe the correlation of the graph or data graphed in the scatter plot. Well, this graph has test scores on the y-axis and hours of studying on the x-axis. What's happening is that this is going up as x increases, y is increasing. So it has a positive correlation. Now what the graph is saying, though, is that as your hours of studying go up, your test scores go up. So you could say studying up, your scores go up, which would make sense because the more you study, the better you're going to do on tests. Here on this graph, it says the hours of television watched and the test scores. So this one looks like it's going downhill. So that has a negative correlation. So this one is as the TV goes up, so as the X goes up, your test scores go down. Now it says, using the scatter plots above, predict a reasonable test scores for 4.5 hours of studying and 4.5 hours of television watched. So if we look at the hours of studying, if I go to 4.5 hours of studying, that could be about here. Then I go up until I hit my test scores. My test scores would be about there. That's about a 70. So for studying, they got about a 70 on their test. Now 4.5 hours of watching TV, that's about there. They got almost 80, maybe about 77. So TV, they got about an 87 maybe. No, not 87, sorry, 77. So in this particular graph, you get a higher score when the TV is being watched, but these might not be the same people. They might be different points of data. Now, it's asking what is the equation of this line? So it's saying to find y equals mx plus b. So if we find mx plus b, we gotta find m first. Now to me, it looks like this line is going downhill, so I can count down my rise over run. I'll go down -1, -2, -3, -4, negative 5, negative 6. And I'll go over 1, 2. So negative 6 over 2, or our m is negative 3 over 1, which is just negative 3. Now our b, we don't know where b is because we haven't found that yet, and our graph does not cross the axis, our y-axis. So what we can do is we can pick one of our points. I'm going to pick this 4, 5. I'm going to put 4 as the x because that's in the x spot, and the y is 5. So we'll have 5 equals our m, which we found was negative 3, times 4 plus b. This will give us our b. So negative 3 times 4 gives us negative 12, plus b equals 5. I add 12 to get b by itself. B equals 5 plus 12, which is 17. So our new equation then is y equals negative 3x, because that's our slope, plus b, which is 17. Now, how we're going to use a line of fit to model data. So what a line of fit is, or it can also be called a line of best fit. It's a line that goes through our points on a scatter plot that could give us an equation that shows us the trend. So step 1, it says make a scatter plot of the data. Step 2, decide whether the data can be modeled by a line, so if it's positive or negative. Draw a line that appears to closely fit the data. There should be approximately as many points above the line as below it. So if I were to draw a scatter plot here, I would have points going up like this. What a line of best fit is, or a line of fit, is if I drew a line straight through my points. As it's going up, my line is going up. Then it says write an equation using 2 points on the line. The lines do not have to represent actual data pairs, but they must lie on the line of fit. So let's start with this one. This one says draw a line of fit for the scatter plot, write an equation of the line. Well, we already have our line of fit. The scatter plot is going positive, and so is our line. So what we need to do is find 2 points on our line of fit. Our first point looks like it could be right there. Our second point, I'm looking for points on the intersection. Looks like we could have a point right there. So we have 2 points. One is at negative 2, negative 5, and one is at 3, negative 1. So what we're going to do is we have to find y equals mx plus b. Now because we have a line, we can just count rise over run to find m. So we can go 1, 2, 3, 4. And then 1, 2, 3, 4, 5 as our run. So our slope is 4 over 5. Then, what we can do is pick one of our points. I'm going to pick 3, 1, or 3, negative 1, I mean. 3 is our x, our y is our negative 1. So we have negative 1 equals 4/5 times 3 plus b. Four fifths times 3 gives me 2.4 plus b equals negative 1. Now I'm going to subtract 2.4 to get b by itself. Negative 1 minus 2.4 gives me a negative 3.4. So Negative 3.4 equals b. So our new equation then is y equals 4/5 x minus 3.4. Now we can check to see if that's reasonable, because our b is where our line crosses the y-axis. If it crosses it at negative 3.4, we know that we're pretty close to this. So if we go down, there's negative 3, there's about negative 3.4. So we know that we got pretty close to this. It may not be exact because of our points, but we are very, very close. Alright, so it says make a scatter plot of the data, describe the correlation of the data. If possible, fit a line to the data and write an equation of the line. Well, it looks like we already have our scatter plot made out, and our line of fit. Looks like it's going positive to me. So I'm going to find 2 points on our line here. Looks like we have one very close to here and one very close to here. So we have to find y equals mx plus b. So our m, we go up 1 and over 2. 1, 2. So m is 1/2. Then we got to pick a point. I'll pick this one, which is 1, 3. So our y is 3. We have 1/2 times 1 plus b. 1/2 times 1 is 0.5 equals 3 plus b. Subtract 0.5. And we get 2.5 equals b. So we can check to see if that's reasonable. If our line crosses at 2.5, that's pretty close. So that is reasonable. Our equation would be y equals 1/2 x plus 2.5. Alright, that's it for today. Grab your homework. This is a 3-page assignment, but we're going to spend 2 days on scatter plots, so you only need to complete this whole 3-page assignment in the next 2 days.